Hi everyone, so today we're talking about proteolytic enzymes. These are basically enzymes that break down proteins into peptides and amino acids. Now you may be wondering what are peptides? These are basically oligopeptides which have around 2 to 10 amino acids. And the proteins they're broken down by breaking apart their peptide bonds. Now proteolytic enzymes they are divided into two categories according one is according to the site of action and the other is according to their physiological focus. In other words, what part of the body they particularly focus on and digest the proteins in. So first of all, according to the site of action, you have endopeptidases and exopeptidases. Endopeptidases cleave internal peptide bonds, whereas exopeptidases they cleave terminal peptide bonds. Endopeptidases examples are pepsin, trypsin, chymotrypsin, and elastase. So very simple: pepsin, trypsin, chymotrypsin, and elastase. Whereas exopeptidases examples are aminopeptidases and carboxypeptidase. Aminopeptidases, as suggested from the name, it removes amino acid from the N-terminal, as carboxypeptidases removes amino acids from the C-terminal. Now, when you talk about the other category, now this was according to the site of action. When you talk about the other category, which is digestive proteolytic enzymes, in accordance with the physiological focus. So you have gastric proteases, you have a lot of pancreatic proteases. You just have one gastric protease, and then you have multiple pancreatic proteases, and then you have intestinal proteases. So first of all, gastric, then pancreatic, very important, pancreas, related to the pancreas, and then you have intestinal proteases. So when you talk about gastric proteases, you just have pepsin. Pancreatic proteases, you have trypsin, chymotrypsin, elastase, and also carboxypeptidase, which is an exopeptidase. The rest all are endopeptidase. This is also an endopeptidase. Remember we said endopeptidases as pepsin, trypsin, chymotrypsin, and elastase. Then you have intestinal proteases. You have aminopeptidase, dipeptidase, and tripeptidase. So again, gastric protease is pepsin. Pancreatic proteases are trypsin, chymotrypsin, elastase, and carboxypeptidase. So don't forget these. And then you have intestinal proteases, aminopeptidase, dipeptidase, and tripeptidase. Now, when you talk about pepsin, this is activated. First of all, this is secreted as inactivated form, which is of pepsinogen. So this is the inactivated form, pepsinogen. Now, this pepsinogen this is inactivated and it has to be activated by HCl. So pepsin in stomach is activated by HCl. Good. So this is optimal pH. Now pancreatic proteases, these are secreted as inactive zymogens. So what are the inactive zymogens? Trypsin is trypsinogen, chymotrypsin is chymotrypsinogen, elastase is proelastase, carboxypeptidase is procarboxypeptidase. Alright, so these are the inactive zymogens for pancreatic proteases. Now these are activated by enterokinase or enteropeptidase. Trypsin particularly, this is activated by enterokinase, and then rest all are activated by enterokinase plus trypsin. So trypsin is going to activate the rest easily. Now these most proteolytic enzymes are secreted as inactive precursors that prevents the autodigestion. Trypsin, for example, you do not want autodigestion of the stomach, you do not want autodigestion of pancreas or intestine. Now trypsin activates all other pancreatic proteases. So trypsin is activated by enterokinase, but then it activates all the other pancreatic proteases. Then you have proteolytic enzymes that are essential for protein digestion and absorption. Proteolytic enzymes are essential for protein digestion and absorption. So this is like one thing. Now, why is activation needed? Most proteolytic enzymes are secreted as inactive precursors or zymogens. This prevents autodigestion of stomach, pancreas, and intestines. Now, when you talk about gastric proteolytic enzyme, which was pepsin, was secreted as pepsinogen from the chief cells. So chief cells are going to secrete pepsinogen, right? And then you have this is activated by HCl, and pepsin then autocatalytically activates more pepsinogen. So pepsin, first of all, some bits of pepsin are activated by HCl, then the remaining bits of pepsin are activated by pepsinogen are activated by pepsin itself. So autocatalytic activity. And then this breaks because this is an endopeptidase, so it's going to break internal peptide bonds. Then moving forward, pancreatic proteolytic enzymes. All are secreted as zymogens. The key initiator is enterokinase, and then it activates trypsinogen into trypsin, and then trypsin is going to activate the remaining pancreatic zymogens. Trypsinogen activator is enterokinase, and then it also activates all the other pancreatic proteases. Then you have chemotrypsin. This is secreted as chemotrypsinogen. It is activated by trypsin. Elastase, it is proelastase, it's activated by trypsin. Carboxypeptidase, an active form is procarboxypeptidase, activated by trypsin. Then you have aminopeptidase. This is already active, so it doesn't have any zymogen, and it breaks the N-terminal bonds. This breaks the C-terminal bonds. Then these dipeptidase and tripeptidase, these are also active enzymes. This is a quick summary. Stomach. It is a gastric proteolytic enzymes are pepsin. Intestinal are pancreatic proteases. So these are in the intestinal lumen. Then you have brush border peptidases, and these are the products. So pepsin makes proteases and peptones. Pancreatic makes oligopeptides and amino acids and amino acids. And this is another summary table. Pepsin is activated by HCl, and the remaining pepsinogen is activated by HCl into pepsin. The remaining pepsinogen is activated by pepsin. Then you have trypsin. So trypsinogen is activated by enterokinase.